So I wanted to show off this fully functioning CPU that I built on logism. It's pretty basic, but it's a complete processor. It handles I type, R type, and J type instructions. And I just wanted to kind of show it in action. So you can see here we have our instruction memory, where how this works is you can load in programs. So you do it like this, and then here's some programs that I have that can run on the CPU. To start, I'll just show you bubble sort. And here we have our PC right here. We've got our registers. This is our data memory, our RAM right here, the ALU. This is the control unit. All these were custom. I've built these elements custom. I just use the built-in ones to construct the CPU, but in the future I plan to completely from scratch build a CPU. But yeah, basically how this works, this bubble sort program, is you load in to the RAM. The first value is the length of the array, and then so I'm going to say it's in a length of length 4, and then my first value is 7, then 3, then 1, then 9. And then you reset the program. As you can see, the register file will switch to all zeros when I click this. And then you run the clock, and it should sort this array. So you can kind of see it running. On the left, on the ROM, it'll go through, and it kind of jumps through this program a few times, because that's how bubble sort works. And once it starts going through the zeros, then you know it's finished. And you can see it goes 1379. So it did in fact sort using bubble sort, which is pretty cool. Let's load another image, another program, just so you can see how this works again. We can do the Fibonacci sequence right here. I believe the way this one works, let's reset, is you put into the first value of RAM the number that you want, however many Fibonacci numbers you want to. So for example, if I want to load up to the 5th Fibonacci number, it'll put in RAM 1, 1, and then 1, and then 2, and then, or no, 1, 1, 2, 3. It'll just do this Fibonacci sequence. So let's see it in action. Let's run it. So yeah, it goes 1, 1, 2, 3, 5, and those are the first 5 Fibonacci numbers. So that's another pretty simple program. Let's do one more. This one's a little bit more complex. Definitely the most complex program that this thing can run, but it's the factorial. This is cool because it uses the stack, and it uses jump and link and jump register instructions. So let's, the way this one works is you put in RAM of 0, the number that you want factorial of. So let's just do 5 again, I guess. The factorial of 5 is 120, and it'll store this value in the R1 register. So let's restart, start the clock. Kind of a slower program. You can speed it up a bit. And there we go. R2 stores a value. Sorry, I think I said R1, but it's R2. Stores a value 120, which is in fact the factorial of 5. So that's how my CPU works, made from scratch.